Hello everyone and welcome to our YouTube channel. Our topic for today is instruction pipeline, implementation and advantages. This video is presented to you by group E11 and here are the points that we will be discussing today. Introduction to instruction pipeline, pipeline processing, implementation and advantages. So without any further ado, let's get started. The instruction pipeline is a key component of modern computer processors that allows efficient execution of instructions. It is a technique used to increase the throughput and performance of a processor by overlapping the execution of multiple instructions. The pipeline divides the process of executing an instruction into a series of stages. These stages typically include instruction fetching, instruction decoding, operand fetching, execution, memory access, and write back.
Multiple instructions can be in different stages of execution at the same time, which enables higher throughput and better utilization of the processor's resources. Instruction pipelines can vary in the number of stages and the specific tasks performed in each stage depending on the processor's architecture. Instruction pipelines can vary in the number of stages and specific tasks performed in each stage, depending on the processor architecture. Additionally, pipeline efficiency can be affected by various factors like data dependencies, branch instructions, and memory access latencies, which may introduce stalls or delays in the pipeline. The instruction fetch stage retrieves the next instruction from a memory and stores it in a buffer. The instruction decode stage decodes the instruction and determines the operation that needs to be performed. The execute stage performs the operation. The memory access stage accesses the memory if necessary, and the write back stage writes the result back to memory.
A four-segment instruction pipeline. A four-segment instruction pipeline unifies two or more distinct segments into a single unit. For example, the decoding of the instruction and the calculation of the effective address can be merged into a single segment. A four-segment instruction pipeline is illustrated in the block diagram. The instructional cycle is divided into four parts. Segment 1. The implementation of the instruction fetch segment can be done using the FIFO, that is, first in first out buffer. Segment 2. In the second segment, the memory instruction is decoded and the effective address is then determined in a separate arithmetic circuit. Segment 3. In the third segment, some operands would be fetched from the memory. Segment 4. The instruction would finally be executed in the very last segment of a pipeline organization.
Now the next point is pipeline processing. Pipeline processing. So pipeline processing is a technique used in computer systems to improve performance by overlapping the processing of different instructions. The idea is to divide the execution of an instruction into several stages and then execute each stage separately. As one stage of an instruction completes, the next stage of that instruction is started, when the first stage of the next instruction is started in parallel. This allows multiple instructions to be processed simultaneously, leading to a significant improvement in performance. As the instruction moves through the pipeline, each stage completes its operation and passes the instruction on to the next stage. Then there is pipeline processing flowchart. As per shown in the figure, pipeline 1 consists of fetch, then decode, then execute. Pipeline 2, first decode, then execute, then fetch. Pipeline 3, first execute, then fetch, then decode. Thing to be noted is that each pipeline is a separate part of the CPU.
Now that we've seen pipeline processing flowchart, let us move towards implementation. Now there are various stages of implementation. First being instruction fetch stage. In this stage, the CPU fetches the next instruction from memory and loads it into the instruction register IR. The second stage is instruction decode stage. In this stage, the CPU decodes the instruction in the IR to determine the type of operations to be performed and the operands involved. The third stage is execute stage. In this stage, the CPU performs the actual operation specified by the instruction using the operands obtained in the previous stage. The fourth stage is memory access stage. In this stage, the CPU accesses memory to read or write data as required by the instruction. The last stage is write back stage. In this stage, the CPU writes the result of the instruction back to the appropriate register. In the next slide, you can see the flowchart of these stages. So first is your instruction fetch stage, second is your instruction decode stage, third is your execute stage, fourth is your memory access stage, and the last being your write back stage.
Implementation you saw in the slide before this assumes a basic 5-stage pipeline. In practical, pipelines can be much more complex with additional stages and various optimizations to improve performance. For example, modern CPUs often have pipelines with more than 20 stages. So to the next slide, advantages of pipelining. First advantage of pipelining is faster execution of time. The main advantage of instruction pipelines is that they can significantly increase the speed at which instructions are executed. By breaking down the execution of instructions into smaller steps and executing these steps in parallel, pipelines can achieve much faster execution times than traditional single stage execution. The next advantage is efficient use of resources. Instruction pipelines can make more efficient use of resources such as the CPU and memory. By allowing multiple instructions to be executed simultaneously, pipelines can keep the CPU and other resources busy, reducing the amount of idle time and increasing overall efficiency.
Advantages of pipelining: higher clock frequencies. Instruction pipelines can also enable higher clock frequencies to be used, which can result in even faster execution of times. This is because the pipeline can keep the CPU busy even at high clock frequencies, making it possible to achieve faster execution of times without sacrificing the performance. Improved performance. We know that performance is inversely proportional to the execution of time. By allowing multiple instructions to be executed simultaneously, pipelines can improve the performance of the CPU. This can result in faster response times, improved throughput, and better overall performance for applications that require higher processing power. These are the references. That's all from our side. Thank you so much for watching this video.